What's up people, this is Vishal, and in today's video I'm going to talk about the differences between set and weak sets, and we will practically see the differences between them and compare the memory graphs and so on. So by the end of this video you'll definitely learn something new, so let's go. Let's look at the basic differences between sets and weak sets first. So weak set can only store objects, unlike sets. So sets can store anything, it can be number, string, boolean, whatever, but weak sets can only store the objects. Second difference is weak sets hold a weak bond to the data being stored and hence can be garbage collected. So my video is going to majorly focus on this difference, and we will be doing a practical and seeing this difference, and we'll get back to this. But the other difference is it only has the functions like add, delete and has, and the weak set is not an iterable, and you cannot iterate over the weak set. Okay, so these are the basic differences. If you have not watched my garbage collection video yet, I've added the link in the suggestion box. I recommend you to go and watch that first, because we are going to use similar terminology in this video as well. So I recommend you to go first to check that out and come back to this. So let's get into the code now. So I've already created a class called dataset, which is holding a value called data, and which is assigned to a very huge string. The way I've created a string is I've used new array, added a very huge array length, and I'm joining everything with a pipe. So this is going to basically create a very huge string. And what we do next is I'll create a variable called store with an empty object, and I'll say store.dataset equal to new dataset. So I'm basically creating an object of this class and assigning it into store.dataset. Now another thing that we are going to do, so before we jump into weak set, we'll first see what set does. So we'll first create a set, and inside the set I'm going to add my store. Okay, so let's head on to our browser and try to execute our code. So I go to my browser, open my console, and before I hit a refresh to execute my code, I want to talk about the memory tab. So on the memory tab, you will need to click on record call stacks. Okay, so I'm sure there are similar tools available on Chrome as well. I'm talking in terms of Firefox right now. So once you have selected record call stacks, you need to hit a refresh. And once I hit a refresh, this code gets executed. I'm working with a huge data over here, so it is going to take some time, so let's wait. Alright, so my website is now loaded. The code has been executed. Now once the record call stacks is selected, I can click on take snapshot. So we are basically taking the snapshot of the memory being used by each process. So if you see here, the strings is taking the majority of the space, and that is 95 MB, and I'm pretty sure that the huge data that we created here is contributing a lot to that memory. So we are not interested in tree map, so we'll head on to aggregate and choose the type as call stack. My script name is WeakSet, so let's filter it by that name. Okay, so WeakSets is basically doing all these things, like all the memory allocations are happening over here. I'm more interested in this part, which is on 1317, right? So on 13th set, I'm basically creating the object for this particular class, right? So this is going to take the most amount of memory. Hence, we are going to look at this particular entry and click on these three dots, and you can see that 93% of the memory is consumed, or the string or this class is basically contributing towards 93% of the memory that is being consumed. So once I click on this is very important. So let's look at this graph. So in this graph, you can see that this object that I just created by choosing new dataset is getting referenced by two things. One is store dataset and the set, right? So it is getting referenced by store.dataset plus in the set also, correct? So now if you remember from my last video where I talked about garbage collection algorithms, there was one algorithm which was reference counting algorithm. The algorithm is pretty straightforward, and I've already explained what that means in my previous video. So if you have not checked it out yet, click on the suggestion box and please check it out quickly. And yeah, so now currently the references to this object are 2, hence the garbage collector will not be clearing this object, right? So let's try to delete the reference. So we'll delete one reference, which is the store.dataset. So I deleted this. We'll go back to our memory. We will take a snapshot again, and you'll see that there is no difference in the memory allocation that is done by my WeakSet scripts, right? But there is one difference in the graph that we created, that we just saw. In the graph, you will see that there is only reference to set, right? But the reference to the store has been deleted. Now what we understand from here is the reference counting algorithm is, when it runs for garbage collection, it will see that there is still a reference to that object and it will not delete that object. Hence the memory consumption is still similar from the last step, right? So there is no difference between the weak set. So though I have deleted the reference, set is still holding that reference and it is creating, still consuming the same amount of memory, even though I have deleted it. Alright, so this is what the set is doing. Now let's modify our code to use weak sets. So we'll use weak set now, and let's rename this as well. We'll call it weak set. Let's copy and paste here. Yeah, so now my code is going to use weak sets. So let's see what difference it creates. So we head on to our browser, hit a refresh again. It is still going to create the same huge object and still going to store it in the memory. So on the first load, when I have not deleted the reference for store dataset, I think the memory consumption will still be same. So let's wait for the website to load. Okay, it loaded now. So let's take a snapshot again. And if you see the snapshot, the size is still the same. There is no difference in the size consumption, but you will see one difference in the graph. So let's go to the graph and select this. So once I select the graph, you will see that there is only one reference, which is store.dataset. There is no reference created for weak set, right? So as I explained in the starting, so weak set is going to create a weak bond, so it is not going to actually create a reference in the memory. Okay, so hence we are just seeing store.dataset over here. Now according to the reference counting algorithm, right now the count of the references is just 1. So if I delete this, the garbage collector should do its magic and clear the space that was allocated for this particular object. Alright, so let's do that quickly. We go here, we delete the store.dataset, and let's take a snapshot again. So we'll head back and we'll take a snapshot again. As you can see, there is a drastic difference between the new snapshot now when I'm using weak set, right? So when I'm using weak set, you'll see the difference between these two. So you can use the comparison tool. So first two are the ones which I took via set. The next two are the ones which I took via weak set. So the difference, you'll see that there are some negatives over here. So total count is reduced by 1, right? So what that means is total count we had was 2, like on the whole it was 2, 1, 3, 4, 5, right? But when we came here, one of the references is gone, right? So one of the counts is gone, and when I go back to our graph, that huge memory allocation that we did for the string is not there anymore, because the reference is gone, and hence the garbage collector has freed up that space, and hence you're seeing this huge difference in the storage. In the end, I'd just like to conclude that if your use case is just limited to checking whether an object is present in a set or not, you're working with very huge data, and that's the only use case that you want, weak set will be much more performance efficient compared to the sets. And in my next video, I'll actually show you a real-time use case of weak sets. And that's all for this one. So If you have any questions, just drop a comment in the comment section. Like and share my video, and subscribe to my channel for more such interesting content. So that's all for this one. Bye.